Hi there, this is Penelope. This is the second in probably a series of two videos on finding centroids. This one is going to look at finding the centroid of a trapezium and finding the centroid of a composite shape. Now this one is a trapezium, and if I just call that A and I call that entire distance there B and I call this height H. Now X bar is going to be halfway along B. So half of B would be 0.3 plus 0.5 plus 0.6. So 0.3 plus 0.5 plus 0.3 over 2 is going to give us, 1.1 over 2. That'll do fine for the moment. Now the Y bar is going to be something that we have to find. Now for a trapezium there's actually a formula, and the formula says H over 3 times B plus 2A over B plus A, where A, B and H are as in the diagram. So H is 0.5 over 3 times B, which is the whole length, which is 1.1, plus 2 times A, so that's 1.2 all over B plus A. So B is 1.1 and A is 0.6. So if you do that on your calculator, you get that Y bar is equal to 0.225. So that's finding the centroid of a trapezium. Now here's a complicated shape. It's got a semicircle on the end of a rectangle which has a triangle popped on the top. So let's name the areas that we're going to look at. Let's call this 1, call this 2, and call this 3. So what we need to do is we need to find A1, X1, Y1 and so on. A1, the area of the rectangle, that's easy, that's 80 by 20. Whoops, don't know what that is. 80 by 40, so that's 3200. A2, the area of a triangle, is the half the base times the height, so that gives you 800. And the area of the semicircle is going to be pi r squared. Pi r squared over 2, or a half times pi times 20 squared, and that would be 200 pi. And if we wanted in a number, it would be 628.31. Now we need to find x1. Now x1 is going to be, x1 is going to be halfway along this semicircle and the rectangle. So it's going to be 20 plus halfway along this 80, so it's going to be 20 plus half of 80, so it's going to be 60. So I can put that in there. x2, now x2 is going to be, now for a triangle there are some rules for different shapes, and for a triangle the centroid is, sorry about that, we're just finding x2. Now x2 is going to be this 20 of the semicircle plus halfway along the rectangle, so that's 20 plus half of 80, which is 60, plus half of this bit here of the triangle, so that bit there is 40, so that's plus another which is 80 all up. So 20 plus 40 plus another 20, so that gives us 80. Now for the y2, we'll come to that in a minute. Let's have a look at x3. x3 is just going to be one of those ones that we know that for the centroid of a semicircle, the x value is going to be at 4 over 3 pi, and it'll actually be 20 minus that. So 20 minus 4 times, now r is 20 over 3 pi, and if we use the calculators, that's 11.52. Okay, going back to y1. y1 is just going to be half of 40. So that's 40 from there to there. So it's going to be, so that's 20. y2. Now, y2 is another one where we're going to know the rule. y2 is going to be the centroid of a triangle is a third of the way up the height. So that's 40 divided by 3 plus halfway up this as well. So that's plus 40, which gives us some funny number, 53.3. And for A3, the corresponding y3 is just going to be halfway up, which is going to be 20. Now, we've got all our numbers. All we have to do now is put them into the rule that says x1 is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3, and if you do the number crunching, that's just over 56. And for y bar, it's going to be a1 y1 plus a2 y2 plus, now what I should have done actually is I should have put in the axes. Whoops, it's not a very good one. So that there's my x-axis and there's my y-axis, otherwise it doesn't work. So what were we up to? Y bar is a1 y1 a2 y2 a3 y3 over a1 plus a2 plus a3. Do the number crunching on your calculator and you get 25.76. So that means that the centroid is going to be 56 centimeters along. So there's 20 halfway along there, that's 60. So it's back a bit from halfway. So it's about there, up 25. So maybe about there. So the centroid is about there. So that is 56.8. Well, I don't know, 56.88, and this one is 25.76. And there we are.